Hi guys, this is the last lesson of the course. This is cosine law, and it is dealing with, once again, triangles that are non-right triangles. With primary trig ratios, reminder that you can only use them for right triangles. That means triangles that have a 90-degree angle. So that was SOHCAHTOA. That's still on part of the quiz, so make sure that you've reviewed SOHCAHTOA and you understand when to use it. And then last week's lesson was on sine law, and sine law can only be used if you know a complete pair. So remember what that means. That means knowing an angle and a side that go together, that are across from each other. So you either know capital A and lowercase a, or you know capital B and lowercase b, or you know capital C and lowercase c. So as long as you know a complete pair, you can use sine law. So what happens if you do not have a right angle and you do not have a complete pair? So let's say we know this is 10. Let's say we know this is 40 degrees. And let's say we know A is, 12. In this case, we don't have a complete pair. We know angle 40, but we don't know the side across from it. We know side length 12, but we don't know the angle across from it. And we know side length 10, but we don't know that angle across from it. So there's no pair there. And then the other time where there's no pair is if we knew, let's say this was 10, this was 12, and this was 13. There's no complete pair here either because we don't know any angle in this triangle. So we don't know the angle that goes with 13, we don't know the angle that goes with 12, or the angle that goes with 10. These are the two cases where there's no pair and you would have to use cosine law. So there are two versions to cosine law. One of them determines a side length. And notice it's very similar to Pythagorean theorem. What it actually does is it does a bit of Pythagorean theorem and it puts on this ending part to consider the fact that it's not a 90-degree angle. Okay, so remember Pythagorean theorem only works for right triangles. And then what this does is it takes into account that it's a non-right triangle. So this one is used for this first situation if you know two side lengths and the angle in between. So this is when you are solving for a side length. And then the second formula is when you're solving for an angle. And it's cos A equals B squared plus C squared minus A squared, all divided by 2 times B and C. And this is solving for an angle. All right, so we are going to choose the formulas that we want to work with to solve a couple questions. So we've got this formula and this formula. All right, so once again, cosine law can be used whenever you can't use sine law. And it's used when you know 3 sides and want to find an angle. That was actually this picture. We know all 3 sides here, and we don't know any angles. And then the second scenario is used when you know 2 sides and the angle between, and you want to find the third side. That was this situation. You know 2 sides, you know the angle between, and you want to find the third side. Okay, those are the 2 times we're going to use it. We're going to start with this first situation here on the left because it's a little bit easier. So we're going to use this version of the formula first. All right, example 1, we're going to draw the triangle DEF, and then we're going to solve the triangle. So draw any random acute triangle. We can put D, E, F wherever you want. And then we have to put in the information given in the right spots. So lowercase d is 4.9. That would be across from capital D. Lowercase f is 6.2. And they give us capital E is 64 degrees. Okay, so this triangle is not in terms of A, B, and C, but that's okay. The whole point is it has two sides and it has an angle between the two sides. So what this is called is it's called side angle side, SAS for short. And in SAS, we're going to use the cosine law to solve for lowercase e, because we're always going to be able to solve across from the angle given. So if we go back to this version of cosine law, in our case here, we're going to solve for lowercase e. And because we're solving for lowercase e, this just means we're going to fill in the side lengths we do know. So let's do that. So e squared equals, we're going to use side lengths d and f. And the cosine law states that whatever two letters you use here and here, use the same two letters here and here. And whatever letter you begin with, if you're solving for lowercase e, you have to end with the capital angle to what you're solving. So let's compare that back to the ABC formula again. Notice again, since we were solving for A here, it matches with angle A. So these two will always match. And then whatever two letters you use here and here are the same two letters in this part of the formula. Okay? And these two letters are the sides that you know. And this is the angle you know. So it's the known angle. All right. So let's fill it in. Lowercase d is 4.9 squared. Lowercase f is 6.2 squared. Minus 2 times those same two numbers, 4.9 and 6.2. They're not squared in this part of the formula, just in the first part of the formula. And we're going to times that by the cos of the angle, which is 64 degrees. Now, please get used to using your calculator fairly efficiently. What that means is try and do this all in one step and get comfortable with typing all that in. So basically you're just typing in 4.9 squared plus 6.2 squared minus 2 times 4.9 times 6.2 times cos 64. Unless you're working with a backwards calculator, you should be able to do that all in one line. Okay? I will break it down for you right now because it's the first time you're seeing it, but I would prefer if you are basically just able to type it in and have an answer. So I typed in 4.9 squared, I typed in 6.2 squared. This last part, 2 times 4.9 times 6.2 times cos 64, those are all being multiplied together. There's no signs. So this I definitely want you to type in one step. So just, we're going to do minus, and then we're just going to get that answer. So 2 times 4.9 times 6.2 times the cos of 64. That ends up being 26.64. Just going to round it. And then we can just add 24, 38 and subtract the 26. And you get 35.8. And then to get rid of the squared, the opposite of squaring something is square rooting both sides. So we get E equals the square root of the 35.8, which is 5.98. I'm actually going to round that to 6.0 because when you round the 0.98, it's going to round up to 6.0. So we just figured out this side to be 6.0. This question is asking us to solve the triangle. That means it wants everything about the triangle. So we now have to find angle D or F. I'll start a different color. Let's go with angle D. Let's solve for that. Keep in mind, now that we've done 6.0, we have a complete pair now. So we have a side and an angle that go together. We can actually use sine law now to solve for angle D. So this is a good recap of last week's where we did sine law. We're going to do that again. Since we're solving an angle, we're going to go angles on top. So sine of D pairs up with 4.9. And the pair that we know is the capital E and lowercase e. So we've got to go sine 64 pairing up with 6.0. Bring 4.9 up so we can get sine D by itself. So 4.9 times the sine of 64 divided by the 6.0 is 0.73, and it keeps on going. Leave that in the calculator, don't clear it. Get rid of sine by doing the sine inverse, because anytime you do sine inverse, that's what's solving for an angle. So we're going to take that 0.73 long number that's on the calculator, and we're just going to go sine inverse equals 47 degrees. Okay, at this point we have 2 of our 3 angles. We've got all 3 sides done because they gave us 2 of the 3 to begin with. All we have to do is solve for angle F, and the quickest, easiest way to solve for angle F, angles in a triangle add to 180, so we can just do 180 minus 47 minus 64. I'm out of space to write that, so I'm just going to say it out loud. 180 minus 47 minus 64 degrees. This ends up being a 69 degree angle. Okay, and the triangle is solved. Let's do another example. All right, so this is a construction site. A third road is planned that will connect a couple towns together, which are 16.5 kilometers apart. So they're telling us that this is 16.5 kilometers apart. So that third road that this construction site is planning. We want to find the angle to the nearest degree between the new road, which is the dotted line, and the existing road from Rolling Meadows to Brookside. So we want to find this angle in here. So angle B. All right, in this case, we know all 3 sides and we know no angles at all. So we're going to have to use the version of the formula that starts with cos. So we're using this version. Okay, keep in mind, this formula is for solving for angle A, and we're trying to solve for angle B in this question. So we're going to start with cos B equals. The way the formula works for solving an angle is as long as you subtract the corresponding side length, then it will solve for the capital angle. So because we're solving for capital B, we want to make sure we subtract lowercase b. I'll compare that back up here. Here we were solving for capital A, and we want to make sure that we subtracted lowercase a. So those two have to match. These two are the other 2 side lengths right beside the angle. So B and C would be right beside the angle. In this case, B and C would be these 2. So if we are solving for capital B, we're subtracting lowercase b, and we're going to call this one across R, and we'll call this one H. So we're going to go R squared plus H squared, And the denominator is always the same two from the original two, r and h. Okay, lowercase r is across from capital R, so that lowercase r is the 16.5. Lowercase h is the 10. And the one that we're subtracting, and the one that's most important, is the fact that you're subtracting the 15, which is across from the angle you're solving. So we're doing 16.5 squared plus 10 squared minus 15 squared. So notice we're basically adding together the two sides that form the angle, and we're subtracting the side across from the angle. And then we are dividing by the 16.5 and the 10 and the times by 2. I'll do the entire numerator. 16.5 squared plus 10 squared minus 15 squared. And on the top you get 147.25. On the bottom, 2 times 16.5 times 10 is 330. And then we are getting rid of cos, so we're going to do the cos inverse of this fraction. So there's a couple ways you can do it. You can go straight to doing the cos inverse and type in that fraction. Or if you prefer, you can divide the fraction first and then find the cos inverse. So I'll say that one more time. You can do the cos inverse and type in that whole fraction, or you can divide the fraction first, get a decimal, and then do the cos inverse. So the cos inverse of the 147.25 over 330 is an angle of 63.49 degrees. So that is just less than half. So we'll stick with 63 degrees. All right, part B is asking us to find angle H. So it's asking us to find the new road. Remember this question wanted the new road and the road from Rolling Meadows to High Cliff. So we'll go different color again. So we are asked to solve for H in this case. Now there's two ways we could do this at this point. We do know the complete pair that we just finished. So we know that this is 15 and this was 63 degrees. We can definitely use that pair and use sine law to solve for capital H. Or we can do cosine law again to solve for capital H. I'd like to review sine law again. However, I don't want you to just have this one example on cosine law. So we are going to repeat cosine law this time. So we are solving for H in this case. That means we're going to have to subtract lowercase h because we're solving for capital H. So we're going to make sure that we're subtracting the 10 in this case. That means R and B. So Rolling Meadows Road across from it and the Brookside Road across from that. Those are the two we're going to be adding. So we're going to take R squared and B squared this time. Again, as long as you're making sure you subtract the one of the one you're solving for, you should be good. So R squared, R is the 16.5. The B squared was the 15 squared. And we're subtracting the one across from the angle we're solving. I'm a little bit out of space here, so I'm actually just going to do that in one entire step. I'm going to do 16.5 squared on my calculator, 15 squared, and I'm going to minus 10 squared. And then I'm going to put the whole thing divided by bracket 2 times 16.5 times 15 and close that bracket. So this time I'm turning it to decimal. Okay, try that on your own. Make sure you got that same decimal. If you need to break down numerator and denominator and divide it separately, that's okay. I was just at a space, so I didn't want to do it in separate steps. And then to get the angle H, we're just going to do the cos inverse of that 0.8025. And you get 36.6, which can round to 37 degrees. This question just asked for those two angles. If we want to solve for angle R, we could just subtract from 180 at this point, but it didn't ask for that anyway. Okay, final question. A boat is sailing north through a narrow strait. Through one particular narrow section, a lighthouse marks the western shoreline, while a buoy indicates a rock hazard directly east of the lighthouse as shown. So we have this picture. What is the width of the strait? So the boat is trying to come through here. So we're being asked what this width is. So the boat is coming north through here. We want to know what length of space the boat has to travel through, right? Because obviously it doesn't want to hit the lighthouse and it doesn't want to hit the rocks. So it has this path to get through. All right, we don't have a complete pair. We know the 26 degrees, but we don't know the side across. We know the 4.5, but we don't have the angle at the lighthouse. And we know the 4.2, but we don't have the angle at the rock. So no complete pair, it's going to have to be cosine law. And since we're solving for side length, we're going to do x squared equals. Now, this triangle doesn't have A, B's, and C's listed. You're more than welcome to put on A, B, C's if you want. So let's do A, B, C. And we're going to do x squared equals, it'll be the other two side lengths. So it's going to be, in this case, B squared and C squared. Because those are the only two side lengths you know. And since we're solving for x, then the angle across from it would be cos of angle A in this case. So we could have called x squared lowercase a as well. I just started with x before I put on the letters. So lowercase b is 4.5. Lowercase c is 4.2. Make sure you square those. That's part of the formula. Lowercase b again is 4.5. Lowercase c is 4.2. And make sure you multiply by the cos of the angle in between, which is 26 degrees. So x squared equals, try it in one step in your calculator. 4.5 squared plus 4.2 squared minus 2 times 4.5 times 4.2 times the cos of 26. I'm going to do it all in one step. And I get 3.91. It does keep going still. Remember, that's not our answer yet, because that is what x squared equals. So the last thing we have to do is take the square root of both sides to get x. And we get 1.978. I'm actually going to round that to 2 decimal places. I know this says nearest tenth of a kilometer, but I think it should be a little more accurate. Let's go 1.98. So that's the nearest 100th kilometer. And that's the distance that the boat has to get between the lighthouse and the rock. Okay, that is it for the course. There will be a trig test posted a little bit later this week, and email me if you have any questions about that. Bye, guys.